Good morning, this is Kavi Priya, Assistant Professor EC Department. I am going to discuss about the topic UJT, Construction, Working Principle, Characteristics and Applications of UJT. And my flow of presentation is, I am going to discuss about the basics of transistor and about the introduction to the UJT, construction, working and characteristics, and finally about the applications of the UJT. First, we can see what is a transistor. So, transistor is a device that regulates a current flow or voltage flow in electronic circuits. So, it is used for amplifying the electrical signals and also it acts as a switch. So, it allows electrical signals to pass through the electron devices or it blocks the electrical signals. So, based on the applied conditions. So, when transistor act as an amplifier, it amplifies a weak signal into a strong signal. Normally, a small amplitude signal will be applied at the base and will be getting an amplified output at the collector of the transistor in case of BJT. Whereas UJT is a three-terminal device, the basic difference between the BJT and UJT is UJT can act only as a switch or a voltage regulator. It cannot be act as an amplifier. Whereas BJT can act as an amplifier as well as a switch and even it can act as a voltage or current regulator. So UJT is a three-terminal device which consists of two bases B1 and B2 and it has an emitter terminal. So the emitter terminal is formed by the heavily doped P-type material and the base terminal B1 and B2 is formed from the lightly doped N-type material. So it has a two base B1 and B2 and the emitter terminal E. And this is a symbol for the UJT. It consists of two base terminals B1 and B2 and it has a emitter terminals. The symbol for this UJT is similar to that of the JFET except there is a bent arrow in case of the UJT. And next is a construction of the UJT and we'll be having a P-type semiconducting material and N-type semiconducting material and we'll be having a single junction. That's why we call it as a unipolar junction transistor. Single PN junction is available in the UJT. There will be a metallic contact from P-type layer which is nothing but an emitter and two metallic contacts will be taken from the N-type layer which is nothing but base B1 and B2. The area between the base B2 and emitter is somewhat smaller in size when compared to this B1 and E. And next is a working of a UJT. So we'll be connecting a supply across between the base B1 and emitter and we'll be connecting a supply across the base B2 and B1. So initially when no voltage is applied across the emitter, the resistance in the particular device will be very high and the device will be turned off. So when the PN junction is forward bias, there will be a positive voltage is applied across the emitter terminal and the base B2 will be made positive and base B1 will be made negative. So since the majority charge carrier in case of the P-type material is a holes. Since base B2 is positively charged, holes will be repelled by the base B2 and it will be attracted by the base B1. So the resistance decreases. Initially, when no supply voltage is applied, the resistance will be very high, so the device is turned off. So when we apply the voltage, the resistance will be decreases and the emitter current will be increases and it will be reaching the peak point and it will be start decreasing. So the point where the emitter current starts decreasing and reaches a point where it increases is called as a valley point. From the valley point again the emitter current will be increases. So when the PN junction is reverse bias, emitter current will not flow and we call the particular region as a cutoff region. And next is the activity of this activity related to the circuits. We have four circuits here. We have to identify the circuits in which the electrical components have been properly connected. The answer is the second circuit B. In case of a circuits, the ammeter has to be connected in series and the voltmeter has to be connected in parallel across a resistor. The condition is satisfied by the circuit B. And next is the characteristics of the UJT. When a supply is applied, when a supply is not sufficient enough, the transistor will be operating in a cutoff region, which means that the supply is not enough. The supply is not reaches the triggering voltage, which triggers the transistor to turn on. So we call in a cutoff region, the transistor will remain in the off state. In case of negative resistance region, we will be applying a supply and the voltage will be increases when the current will be increases and the voltage will also get increased. It will be reaches a peak point and it will be start decreasing. Even though the current increases, the voltage after reaching the peak point will be decreases and it reaches a valley point and it will be start increasing again. So in the valley point, the voltage, emitter voltage will be start increasing again. So when we apply the voltage, this emitter voltage will be increases. As the current increases, the voltage will also get increased at one point called as a valley point. Until the valley point, it will be again decreases and again be increases. So in cutoff region, the voltage will not be sufficient enough to turn on the transistor. In negative resistance region, as the voltage will be increases and reaches a peak point and it drops to the valley point. So even though the current get increased, the voltage will get dropped to the valley point. In saturation region, the voltage will be again start increases. So the voltage and the emitter current will be gradually increases. And next is the advantages and drawbacks of the UJT. Advantage is that it is of low cost and it is a low power observing devices. It is very good at the reverse current. It provides a stable triggering voltage. It provides a very good response, switching response. Drawback is that it cannot be used for high frequency and it cannot be used in all circuits because of the negative resistance impedance property, and important drawback is that it cannot be used for amplification. It can act only as a switch. And finally, applications of the UJT. It is used as a switching device, it is used in the oscillator, it is used in the timing circuit, and it is used in the sawtooth waveform generator, and it can be used for the phase control. And next is the assessment questions. What are all the three terminals in the UJT? It is nothing but emitter, base 1 and base 2. Which type of semiconductor material in which the UJT typically made up of? It is made up of a N-type material and as well as a P-type material. What is the main applications of the UJT? It is meant for oscillation. Main important application of UJT is the oscillations. Oscillator. It is employed in the oscillator circuits. That's all about the construction, working principle, characteristics and applications of the UJT. Thank you.